What up, mathletes? Whoop, whoop. All right, let's get into this. We're doing representative relations, and your learning target is I will represent relations with graphs, tables, and mapping. All right, and your warm-up is for the equation y equals x squared plus 3x minus x. Complete the table by calculating y for each value of x. I'm going to show you how to do the first one. Don't forget to put them in parentheses. So I'm going to plug in -2 for x. So I'm going to have y equals -2 squared plus 3 times -2 minus -2. And it's going to be -2 squared is just +4 minus 6. And those two negatives make a positive plus 4. So this is 4 plus 4 is 8. 8 minus 6 is 2. If you were watching, hopefully you're screaming at the screen going, that's +2, not +4, Mr. Tim. Look at that. I look at that one. Something's wrong with it. That's 4 minus 6 plus 2, which is 0. We're starting out crazy. It's the end of a long day. It's all right. Hey, it's good for you to see me make mistakes and work through it. This is how we do it. 0. Boom. Now let's go ahead, give you a second, pause this, do the rest of them, ready, set, go. All right, I'm assuming you did so let's just bust through it. Y equals, and plug in -1, -1 squared plus 3 times -1 minus -1. So this is 1 minus 3 plus 1. It's going to end up being 2 minus 3 is -1. Plug in 0 for everything. It makes everything 0. 0, 0, 0. So that's just going to be 0. I don't even got to worry about that. How about 1? Y equals 1 squared plus 3 times 1 minus 1. So that's 1 plus 3 minus 1. Those will cancel out, and I'm left with 3. And the last one is 2. Y equals 2 squared plus 3 times 2 minus 2. I guess you couldn't really see the ones, but there we go. So that's 4 plus 6 minus 2. 10 minus 2 is 8. Boom. Awesome. And that is how you find y values in a table. Okay, we got some vocab to fill in, so let's go ahead and do that. We're going to pop over to our screen. Boom. And let's go ahead and write that down. Ready, set, go. A relation is a set of ordered pairs. Ordered pairs are anything in the form of, that should be curved, x, y. Those are an ordered pair, like the point 1, 4. That's an ordered pair. Domain is the set of the first numbers of ordered pairs. So domain is x values. Write that in. And range is the set of second numbers of the ordered pair, which are the y values. It's all the y values. Don't worry, we'll get to that in just a second. Go ahead and write those down. Take a minute. Pause this as needed. We're going to go ahead and move on relatively quickly. Okay, let's read this together. You can use math to represent the relations between two sets of numbers. For example, suppose you record the number of minutes you spend driving for your driver's training course each day for a week. You may use the set 1, 2, 3, 4, 5, 6, 7 to represent the days, and the set 30, 45, 20, 40, 45, 90, 60 to represent the minutes. The relationship between the set pairs each day with the time driven that day. This pairing of numbers is called a relation. The set of days is the domain of the relation, and the set of times is the range. I want you to go ahead on your notes. Let's go back to notes, and we're going to write this information down. You should just be staring at it. I'm going to go ahead and move us back this direction. Let's look. So, suppose you record the number of minutes you spent driving each day for work. You use the sets. So the days are 1, 2, 3, 4, 5, 6, and 7. And days represent the domain, which are your x values. Minutes we were given as 30, 45, 20, 40, 45, 90, and 60. And the minutes represent the range. Again, that is your Y value. Math is always alphabetical also. D comes before R in the alphabet, X comes before Y in the alphabet. See how it works there? The pairing of the numbers is called a relation. I said that a second ago. That's the paragraph I got it from. Or an ordered pair. Oh. Now, the set of ordered pairs is, we're just going to match them up. X, Y, X, Y, X, Y. So, 130, 245, 320, 440, 545, 690, and 760. We have just created a set of ordered pairs to represent this relation right here, okay? And the reason why, another thing that we're going to learn here in a minute, is X is independent. This is going to be independent variable, and this is my dependent variable. Because the time does not, the day does not depend on the time. It's not like I say, oh, Monday we have to go 30 minutes. But on Monday, we went 30 minutes, so the minutes depended on the day, and we'll talk more about that later. But we're going to look at other ways to represent relations. So I want to look at this set of ordered pairs right here. 2, 0, 0, 4, 3, negative 5, negative 3, negative 5, and we want to express this relation as a table, graph, and through mapping. So first of all, let's go this route. We're going to do 2, 0, 3, and negative 3. And what do I know in a table form? I just match it up. The Y was 0. 0 went with 4. 3 went with negative 5. And negative 3 went with negative 5. Okay? Let's do this as a table. Now, when you're doing a table, I want to tell you a couple things I'm always looking for. Number one, always label your X and Y axes. Second thing, I want you to always label the 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. And at times you'll have different scales, but you'll label some of the scales. Basically, we just want to make sure we label the scales. So, 1, label the axes. 2, label the scales. 3, arrows. There's already arrows on the end of each of these, but I always want those included. And when you draw a line, use a straight edge. If it's a curve, then you're going to have to do that to the best of your ability. So let's label this relation right here. We have 2, 0. So X comes first, so 1, 2, and 0. And we have the point 2, 0. Then we have 0, 4. 0, 1, 2, 3, 4. 0, 4. What else we have? 3, negative 5. 1, 2, 3. Down 5. 3, negative 5. And then we have negative 3, negative 5. So negative 1, 2, 3, negative 5. That's the point, negative 3, negative 5. So there's a graph to represent our relation. So we have a table. Up here we have a graph. And the last, this is called mapping. Now mapping, we want to make sure and put it, I like to put it in order. So we're actually going to switch it up a little bit. It would go negative 3, 0, 2, 3. That's how I just put it in order, okay? And let's write down what we have here. So negative 3 goes to negative 5. Or no, now we do our range. And we know negative 3 goes to negative 5. Boom. What does 0 go to? 0 goes to 4. What does 3 go to? Or I'm sorry, 2 go to? 2 goes to 0. And last, we have 3 going to negative 5 as well. Notice we only list everything one time. Why? We don't need to list repeats when we're doing mapping. We just notice that we have 2 arrows going to the negative 5. Okay? So these are 3 different ways to represent information or of a relation. Okay, let's go ahead and go on down here. We got some more vocab to hit up. So we're going to go back to our vocab page. Now, as I kind of talked about earlier, we're going to talk about the independent variable. Again, pause this, write everything down as needed. The independent variable is the variable in the relation, usually x, with a value that is subject to choice. So we can choose any x we want. The dependent variable, once you choose an x and plug it in like we did in our warm-up, it is going to get out a specific y. The variable in a relation, usually y, with values that depend on x. All right, pause this as needed, and we are moving straight on. All right, if you look in the lower right corner of the paper, you'll notice it has that little graph that looks like text messaging. And I just want to walk through to explain what's happening during this whole deal. So we're going to walk through this graph right here. And in the text messaging graph, what's happening in the first little bit? Well, it says as you move from left to right along the graph, time increases and the number of text messages sent increases until the graph becomes a horizontal line. So right here, we see text increasing. Right there, we see text increasing. And I'll be calling it out, but basically I'm just showing it like this, guys. So right here, text increasing, okay? So anything you hear me say, I'm going to come back and show you what it's going to look like here in just a minute. But I'm kind of labeling it as we go. So right here, text increasing. What happens here? The horizontal line means that time is increasing, but the number of text messages is remaining constant. So in other words, no text. And then what do we see? Then she continued to send text messages until she stopped again for a period of time. So, you see, more text. But notice it's not as steep, so not as many as before. And what do we see next after that? Oh, I guess it included that in there. Shows that for this period of time right here where it's horizontal, again, she stopped texting again. Who knows? Maybe it was class time. Maybe there was a Mr. Tim there. Class time. No text. And then last but not least, Nora sends text messages again. Maybe it was the lunch break. Lunch break. More texting. And now let's go back and take a look at what I have going on here, guys. All right, I'm so sorry, that can stay up. Notice, I'm just going to zoom in here. Right here, she's texting, no text right here. And then we circle where it starts going steeper again, more text, but again, it's not as steep as it was before, so not as many as before. Then we have maybe class time. It's a long period of time of no texting. And then we see her texting again, but again, now this is the least steep of all, so I said maybe lunch break, maybe she was eating and texting, so that's why it was such slow responses. All right, there we go. That is just a little story to represent the graph, and we're going to do that over here. We need to match the situation with the graph.